Well, some dimensions of things, these sorts of things are coming up in the modular form.
So the modular form is always the plus a constant. V1 is 0, then the constant is 0. But every one of these holomorphic VOAs, the graded dimension is the J function. You see one that's a J, or you see.
That's kind of
Okay. So, this part was explained by Gail. I will recall this program. For the vertex operator algebra of CSP type, so we can get a real algebra structure on the Wegman subspace by the zeroth product. In addition, we can define the affine real action on the vertex operator algebra, and we get some level. And this will, for the even unusual lattice, the root system determine the even unusual lattice structure. So what corresponds object in the vertex operator algebra should be this real algebra. And the classification of the possible real structure are determined by the Shelkins, and recently AKN and Morales Schattauer given some mathematical proof for it. And let Boolean form of vertex operator algebra in the 24, then V1 is one of the 71 real algebra, and of course is some levels. So by the theorem, the classification problem divided into the two parts. One is for each real algebra in the Shelton series that proves the existence of the form of vertex operator algebra is such real algebra and Wegman subspace. And the next problem is prove the uniqueness of the form of vertex operator algebra of the 24, which is a Buell structure is uniquely determined by the real structure. If we prove 1, 2, then we can say that there are exactly 21 form of vertex operator algebras in the just 24. And 71 is the largest prime factor of the order of the most triple group, and the moonshine vertex operator algebra one of the 71 form of vertex operator algebra. So for the most simple group appear in this story. So and there talk about some new approach and new relation between this 71 and the number of the form of vertex operator algebra. And of course, 71 is important number in this conference. So this is some main problem in this story. And I will explain the current status of this project. Under this project, sometimes called Project 71, and I will explain the current status of this project. And I will explain our recent results related to this project. So let us start explain the construction problem form of vertex operator algebra of center channel 24. And for the lattice cases, so any Niemeyer lattice with roots can be constructed as an overlap of the root of lattice. So this case, so we can start a root lattice and we add a vectors such that the generated lattice is still even and keep the root system. Then we finally get an even unusual lattice. So the natural way is the extension problem of the simple affine vertex space algebra. Because so we know the possibility of the weight one space. So possibility of the real structure of the weight one subspace. So we can get a simple affine vertex space algebra generated by the weight one space. And if we can extend it to the homogeneous vertex space algebra, then we get this is a very simple way to get all vertex space algebra. But this is not easy. So lattice case is a vector, then we get a lattice. But for the vertex space algebra, so we can get a module, but we don't know it has a Voyeur structure or not. This is a very difficult part in this extension program. So we consider the other approach to get a homogeneous vertex space algebra, which is so-called Z-orbital construction. And recently, so Aiken and Moore and Schalter-Hauer established some general theory for it, focused under some assumptions. And sorry, I forget what is N. N is the order of G. So let will be a homogeneous vertex space algebra, and G will be a finite order N. And in the for simplicity, so we assume this is the prime. The Aiken and Moore and Schalter-Hauer discuss a general order, but in my talk, I assume this is the prime. Then we consider the fixed point of G, and this is subvertex space algebra for V, and this V were discussed by Chong In-dong and Jeff and many other speakers. And there is an irreducible GI twisted V module, and such a module is uniquely exists, and which are proved by Chong In-dong, Tyson Lee, and Jeff Nelson. And so we take the irreducible module for every GI, and consider this is an integral with subspace of the twisted module, and we consider direct sum of G with GI and integral with space. Then this is of course GI VG modules, and here we need some assumption. Under some assumptions, so V tilde is a homogeneous vertex space algebra. But so, and this is in a sense we consider homogeneous vertex space algebra, and we consider sub-vertex space algebra, and consider the extension to the other way, and get we can get maybe other homogeneous space algebra. And this would be the Voyeur analog of P neighbor of the lattices. That is in the even in the lattice theory, so we can consider the sub-lattice and consider the extension to the other way, and get the other even in the lattice, and this would be the some this GN orbital construction would be the some analog this fundamental result in the lattice theory. So basically, so we get new homogeneous vertex space algebra by the GN orbital construction. But this is known almost list of the known homogeneous vertex space algebra presented before. And the starting point is the Niemeyer lattice vertex space algebra. So for even Niemeyer lattice, so we can get a homogeneous lattice vertex space algebra. So there are 24 Niemeyer lattices, so we can get 24 homogeneous lattice vertex space algebra. And the lattice vertex space algebra I think first studied by Rochas and the Prengel Postman group. And I think almost property are discussed by Chong In-dong for the representation theory of lattice. And these orbifold construction for the lattice vertex operator algebra and the lift of the minus one isometry of the lattice first studied in the Frege of Lebowski-Mamanzuk to get the Munshine vertex operator algebra. And after that, we can consider the similar method for the Niemeyer lattices, and Durand-Goddard Montague calculated it, and they determined the real structure of the orbifold vertex operator algebra, and they get 15, of course, including the Munshine, the 15 column vertex operator algebra by this method. And I think property first discussed by Abedon and Rio, representation theory of some and after that, created vertex operator algebra are well studied by German and Yamauchi, and I think they, in a sense, they give us some connections between the homomorphic created vertex operator algebra and the binary codes, so-called triply even code. And such a triply even code are studied and classified for the range 48 by maximal one, are classified by Betsmia and Munemasa. And by using their results, so Ram and myself consider the corresponding homomorphic vertex operator algebra, and we determine the real structure of them, and we get 70 homomorphic vertex operator algebra as a thread vertex operator algebra. So, and this looks like looks like different from the orbifold theory, but Ram and Yamauchi's paper, so they use the orbifold theory. In a sense, any form of created vertex operator algebra can be obtained by the not only one time, but several times this orbifold construction from the Niemeyer lattice vertex operator algebra. So this is in a sense this orbifold theory.
So it's always orbifold and minus one, or it's always minus one orbifold, or it's another orbifold?
And here they consider some
coming from the so minus involution coming from the code, right?
Yeah, that's right. Yeah. So that the Niang solution.
There's only in the question.
So yeah, they consider some particular order, not all. And after that, so Miyamoto established the G3 orbifold construction for the lattice vertex operator algebra and the isometry of the lattice of order 3. And he gave an example of the new homomorphic vertex operator algebra by using this method. And Sagaki and myself consider the O Niemeyer lattices and the O isometry of order 3 of the Niemeyer lattices, and we get two more homomorphic vertex operator algebra, and totally we get 3 new ones by this method. And I and Ram consider the orbifold construction for the vertex operator, for any vertex operator algebra and the inner automobiles. So this part, so Google structure part were already done by Don Liam-Mason as an Abelian intertwining algebra and something. And the main key part is the twisted module can be constructed by the delta operator introduced by Ashiri. So this is a very important result in here. And I already mentioned that again, and Moran Shadowhauer established a GN orbifold construction for the lattice particle operator algebra, and they get 5 new ones. And recently, so we consider G7 orbifold construction for the lattice particle operator algebra with RAM. And I will explain the detail later, but they don't consider this case. And I will explain the reason why they don't consider this case. And the third case, represented by the different methods. For example, some of framed vertex operator, forward framed vertex operator algebra are constructed by Gerald-Hen and Shadowhauer, and some of them are constructed by Dong and Zhao and Chu by using Miller extension. So there are several other methods. And in the first version of this slide, I write the remaining one in the problem. But 2 weeks ago, I met Ram in the Sendai, and he told me that he finished the last one. So I take this part and I leave this part to Ram. So I would like to say that up to now, up to this talk, 70 of the 71 are constructed. And the last one will be discussed in the last talk. This is an current status of the construction problem. And let's go to the uniqueness of the common vertex operator algebra of 1024. And I first consider the case V1 is 0. The V1 is 0 case is the same as the conjecture given by Frenkel schema. Such a form of vertex operator algebra is isomorphic to the moonshine vertex operator algebra. This is a still conjecture. And there are some, so in a sense, weak version of this conjecture are proved. If we assume the Griess algebra is isomorphic to the original Griess algebra of the moonshine vertex operator algebra, then the V is isomorphic to the moonshine vertex operator algebra. So, this is proved by Chong Dong and both Griess and Ram. And there are some variants of this such a characterization, but I only mentioned this statement. And if other result is if V is framed, then the V is isomorphic to the moonshine vertex algebra. So this was proved by Ram and Yamauchi. And I think in a sense, weak version of this conjecture, these results. And I will remark that such a vertex operator algebra are constructed in the Frenkel schema book by using the G2 orbifold construction to the Griess vertex operator algebra. And by using the similar, we can consider the similar methods for the order 3 and order 5 and the more general order. And order 3, G3 orbifold construction for the Griess vertex operator algebra are first discussed by Dong and Mason, and these are proved by Miyamoto, I think. But Miyamoto haven't shown that this is the isomorphic to moonshine vertex operator algebra was not so recently. Chen and Ram and me, myself, proved that this vertex operator algebra is isomorphic to moonshine vertex operator algebra. Yeah, I think this is a normal result related to this vertex operator algebra. And let us consider some general case. The problem is that the form vertex operator algebra structure is uniquely determined by the real structure. So, and the known result, first known result is if the real rank is 24, then it is isomorphic to the lattice vertex operator algebra. This is proved by Dong and Mason for in more general situation. And these are just forward for their results. And if V is frame, then the V is uniquely determined by the real structure and the weight one subspace. And run through it. And other corollary, so if the real structure has this shape, and this is so first A1 real structure is A1 16, and this 2 is 11. And this is also real algebra E8, and direct sum of the real algebra E8 and E8, and this real algebra has level 1 versus. And these two cases, so simple affine vertex operator algebra associated with this real algebra are frame. This means that we consider common vertex operator algebra with this real algebra, then the sub-vertex operator algebra generated by weight and is frame. So V is also frame. So we can use our result, and we can say uniqueness of the common vertex algebra.
This was the only new case where Niemeyer one is framed. These are the only ones which are framed besides the Niemeyer. So the Niemeyer.
How many are framed?
How many frames?
I mean, the weight one generally, I think, is still included, except the limits.
So this is the only cases we can use this argument in the frame algebra. So so known result is a simple Niemeyer lattice vertex operator algebra case, and two frame form of vertex operator case. And I will explain there are three cases which are G3 orbital construction. These vertex operator algebra are obtained by applying the G3 orbital construction to the Niemeyer lattice vertex operator algebra. And I will explain this case later. Okay, this is a known result on the uniqueness problem. And let's go to the reverse our recent results. And in our recent results, the key word is reverse orbital. The reverse orbital is a very simple observation, but this is a very useful to get new homomorphic vertex operator algebra and to prove the uniqueness of the homomorphic vertex operator algebra. So let V be a homomorphic vertex operator algebra, and G is an automodule of finite order. And here we assume it is prime order R. And let V G K is a reducible decay system module, and we consider the integral of weight subspace. Then I mentioned that and we assume that we can apply GR orbital construction to the V and G. That is the direct sum of the VG and some integral weight subspace of the system module. This direct sum of this space has a homomorphic structure. And I also mentioned that this is a simple kind of extension with a fixed point sub-vertex algebra created by Z over RZ. This implies that we can define the order R automorphism on this vertex operator algebra, and this is corresponding to the GR gradient. So we can define the order R automorphism. So the reverse orbital means that we can apply GR orbital construction to the resulting homomorphic vertex operator algebra, and this automorphism H corresponds to the gradient, and the resulting homomorphic VOA is V. This means that we start from the homomorphic vertex operator algebra and consider the sub-vertex operator algebra and consider the extension. Then we can go back to the original one by the orbital construction. I think for the expert, this is a very trivial observation. So I and Ram consider the application of this observation.
We will assume that the H is linear automorphism.
Yeah, I don't know, yeah.
Most of the time it's in there, right?
Yeah. But, yeah. Of course, here we assume that the fixed point is a rational physical finite, and then this construction guarantees that there is this twisted module and it has an integral weight space, so we can break we can get the integral subspace of the twisted module as an submodule for the there are two applications. One application is using the construction of the homomorphic matrix operator algebra centered at 24 with the algebra A67. A67 is the real algebra of type A6 is level 7. And this observation is just observation, and we didn't write this part in your paper, so this is in a sense hidden part of our research. And this is probably 2 or 3 years ago. So we have tried to construct such vertex operator algebra by the orbital construction, but this is a level 7, so we have no idea to get it. So last year, I have considered reverse orbital construction, and we assume the existence of the homomorphic matrix operator algebra. This is the starting point. Then we consider what happened. And first, we get inner automorphisms of order set, which is induced from the root system of the A6 that commutes the simple roots, order 7 automorphisms. Then this acts on the real algebra as order 7. And the fixed point should be a 6-dimensional abelian. Then, so we don't know if it acts on the whole space of the order 7, but we assume it is order 7. And we also assume that we can apply G7 construction to VMG. Then we consider the possibility of the real structure of it. And by our experience, so we know some unproved formula, many things, and it seems that the result, weight 1 subspace of the resulting homomorphic vertex operator algebra has a dimension 24, and this implies that this resulting homomorphic vertex operator algebra is assumed to reach lattice. This is just some observation, but if this is true, then it seems that by applying the G7 orbital construction to the reach lattice under some automorphism of order 7, then we get the starting point homomorphic vertex operator algebra such way. Then we try to find the correct automorphism of order 7, and we finally get it. And we get such a homomorphic vertex operator algebra.